All right, guys, so hopefully we understand that quiz or we have questions to come on Monday. Again, please ask questions. Your son is very capable and can help you out as you continue through this lesson. So right now, guys, we're on page 183. Okay, 183, ignore the sloppy handwriting. And we're going to continue to determine the area of composite figures and solve problems using area. We're going to introduce a new figure today, okay? This is something that you will see a lot on 7th grade I-STEP. It is also something that I do want us to know as we're moving forward through this unit. So composite figures may contain parts of circles. To find the area of these figures, it is necessary to identify the radius or the diameter of the circle. So as a reminder, guys, the area of a circle formula is area equals pi times r squared. Okay, just the r gets squared here. So the composite figure shown can be divided into a rectangle and a semicircle. Now, what's a semicircle? Well, let's take a look. Semicircle is an arc whose measure is half a circle. Well, that makes sense. Also makes sense that the area of a semicircle is half the area of a circle with the same radius. So what I want you to see here, guys, is I'm going to do my best to try. Oh, it worked on the first try. So we've got a circle here, and what happens with our semicircle is that we have literally cut this circle in half. Okay, so it makes sense that we would then have to multiply our area by half. So we're still going to use our area formula of a circle. We're just going to multiply it by half when we're done. So what's the diameter of the semicircle? Again, we need diameter or radius to find our area. So the diameter of the semicircle, we'd have to take a look down at the bottom. Well, the length across is 12 inches, so my diameter up here is, again, 12 inches. So then we're finding the total area of the figure, which means we need to find the area of the semicircle and the area of the rectangle. So first let's find the area of the rectangle, which is length times width, which in this case is 12 times 20, 20 times 12. So the area of the rectangle is going to give us 240 inches squared. Area for our semicircle, A equals pi r squared, and again we're going to divide by 2. So it says use 3.14 for pi. So when you plug this into your calculator, guys, it should look like this. 3.14 times r squared. Well, we found the diameter of our semicircle to be 12. So my radius is going to be 6 squared. And all of this is going to be divided by 2. So if we're using our calculators, guys, 6 squared, or 6 times 6, is 36. 36 times 3.14 is going to give us 113.04, and if we divide that by 2, 56.52. And again, we're trying to find the total area. So what I need to do, and I'll move it up here, I'm going to add these together. 240 plus 56.52. Plug that on into your calculator. We should get a total area of 296.52. And again, I always need a label, inches squared. All right, if you're not catching on yet, just hang on for a moment. We'll discuss semicircles a lot more as we continue going forward. Now, the other part of this problem, you guys, is that we need to find the distance around the figure. Well, what is the distance around? Well, that is another way of saying we need to find the perimeter. So finding the distance around the figure. Well, hold on. Real simple, I can find 20 plus 12 plus 20. How am I going to find the length of the semicircle? Well, again, if a semicircle is half a circle, let's find the circumference. So the circumference equals pi times the diameter, or again, 3.14 times 12, which is going to give us 37.68. Now that's the area around the entire circle, and we want half of that. So 37.68, again, divide by 2 is going to give us the length of that semicircle, 18.84. And again, all we did was found the circumference of the entire circle, and we took that by half. So to find the distance around the figure, again, let's go around 20 plus 12 plus 20 plus 18.84 is going to give us 70.84 inches. Again, take a moment, pause this video if you need a moment to either collect your thoughts or write down what's going on in the problem, and we will continue below. Number 2 asks you to use the figure in the My Notes column and see that it's divided into a right triangle and a quarter circle. Well, we all know what a quarter is. There are 4 quarters to a dollar. So, a quarter circle, 1/4 of a circle. It says find the area of the composite figure. Well, we'll do the easy part first. Area of a triangle. Again, area of a triangle is 1/2 base times height. In this case, I have 1/2 times 4 times 5, which gives me an area of 10. And then whenever you see some sort of circle shape, guys, I always want you to start with the normal area formula of a circle, pi r squared. Now you might be wondering what the radius of this circle is, so let's take a look and try and draw another circle here. And let's take a look at this. There we go. Well, the radius is given to us by the figure itself. The radius from the center of the circle, make that a little bigger here. That's better. So the radius, again, is from the center to the side. That's given to us on this figure as being 4 centimeters. So pi times 4 squared, or again, 3.14 times 16 is going to give us our area of the entire circle as being 50.24. Well, again, we don't want the entire circle. We want a quarter of it. We want 1/4. So if we divide that by 4, we will get 12.56. So again, over here, the area of the entire composite figure, if we add 10 plus 12.56, we have a total area now of 22.56. And again, always label. While we're going through this, guys, I don't want you to worry about how much you really understand or how confident you feel with this, because we are going to be spending a lot of time with circles, and I'm very much so will make sure that you understand them completely as we move throughout math this year. So number 3 is going to move us through a problem okay, very one step at a time, okay? So we're going to divide the fragment in smaller shapes so we can find its total area. Now there are lots of different ways that we can do this problem. The first thing I'm going to do is pull out this quarter circle, okay? And the reason why I wouldn't want to draw a line, let's say here, is, well, that's not a figure that I know. So I'm going to try and find something that I know, and I can see a quarter circle. So I'm going to draw my line. From here, some might say, well, I could draw a line going here, but again, that's not a figure that we know. That's not a shape. So I could draw maybe another line straight down for the triangle. And now I have a triangle. We have a trapezoid, a rectangle, and a quarter circle. So this is one way that we could split this up. Now, of course, we could split this up into smaller rectangles, all right? We could split this down here up into another triangle. That is all fine, as long as each shape that you end up with is an actual shape that we have a formula for. So again, triangle, triangle, rectangle, 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 quarter circle. All of these are shapes that we can use to find an area. So go ahead and turn the page. All right, we will skip this right here, finding the total area, and we are going to go straight to number 4. Ooh, leave that here. So this problem down below, guys, is a very, very typical 7th grade I-STEP question. So we start here saying you can break a composite figure into geometric shapes and add the areas of shapes to find the area. That's what we were just doing. Well, if we can add, you can also subtract to find the area of part of a composite figure. So a lot of times, guys, you will see questions that ask, find the shaded region. This is going to lead us through that type of problem. So it says the stained glass design on page 179 contains a circle that fits exactly in a square, as shown. Shade the region that is inside the square, but outside the circle. This has already been done for you right here on the screen. So it's asking you to shade, again, around the circle where you see the teal shading. Describe a method for finding the area of the shaded region. Well, guys, if we think about it, we have a circle, we have a square. We can find the area of both. Now it's asking us to find the shaded region. I only want those teal squares. I don't want the circle. So what if we find the area of the square and subtract, I'm going to make my text smaller here. But what if we find the area of the square and subtract the circle? Because let's say for a moment this entire square is filled in. So we're going to look at this like it's entirely filled in. So I find the area of my circle, of my square, but then we're going back on top of this and we're going to now add or take away a circle. Quite literally, guys, we've erased or we've subtracted what's on the inside of this circle. So now let's try and find the shaded region, or this will be, again, find the area of the shaded region if each square on the grid represents 1 centimeter squared. So let's take this away. So we have 1 centimeter squared on each side, okay? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 centimeters by 10 centimeters. So again, area of a square, length times width. Well, since they're both the same thing, I have 10 times 10, which equals 100. In this case, I just need an area of a circle, pi r squared. Now let's take a look at this. We know we have a diameter of 10, which means I have a radius of 5. And one thing I want to make sure that we know, the radius doesn't have to go straight to the side. It doesn't have to be a horizontal line. This is also 5. Everywhere around this, like a clock, is the same length. So if we use 3.14 times 5 squared, which is 25, again, we plug that into our calculator, we're going to get now an area of the circle 78.5. That worked out pretty well for us here. So again, I only want the shaded region. In this case, that is the shaded part of the square. So my last step is to take 100 minus 78.5, which is going to leave me with a shaded area of 21 and a half. Now, some of you are asking, well, can't I count this? You could try. So let's take a look. I have 1 whole, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are the only whole squares that we have. We can attempt to say, all right, these might fill each other out, those might fill each other out, but we're not going to be very accurate. So if I had that was my, what I was going to say, 13, 14, 15, 16, 17, 18, 19. Let's say these are half, 20, 21. That's still not going to cover what I'm actually going to get here, okay? So don't try to count the shaded area. Okay, we're going to be looking for equations. We're going to be looking for numbers. So we have a check understanding here at the bottom, which is both rectangles. Again, think about the white region here as what's been erased from the problem, okay? We've erased this, we've taken it away. So take a moment here to pause the video and complete the check understanding, okay? We will continue this video, but take a moment to check and ask the sub to check your answers. All right, guys, as you continue to go along with this lesson, the last part is going to be an activity quiz on Canvas. So lesson 17.2 is set up as a Canvas quiz for numbers 7, 8, 9, and 10. Now I want to go through these figures with you before you input your answers. So make sure that you have your book open, ready, and you can write this down. Each one of these is going to use 3.14 for pi. So in your calculator, make sure you are not using the pi button, but you are using 3.14. That will change your answer. Figure 1 is made up of a square, and we can tell it's a square because we have congruent sides. So we have a square and a semicircle. Now again, the semicircle here has a diameter of 4. But if we want to think of this as a radius perhaps, since we're finding area, we have a radius of 2. So for number 7, we are going to be finding our total area by taking length times width plus pi r squared divided by 2. Now be careful, we can't just go plug this into a calculator. Make sure that you are writing it down and you're going over each part. Now number 8 is a bit unique. Okay, if we split this up, we have a rectangle and 2 semicircles. Well, what would 2 semicircles make? Let's take a look. Well, it looks like to me that 2 semicircles would make 1 whole circle. So for number 8, we really don't have to divide our formula by anything. We're simply finding the area of the rectangle on the inside, length times width, and adding that to the total area of a circle that has a diameter of 6 or a radius of 3. Number 9 is the exact same as the problem we had just done, and I will let you know that this is also a square. So again, if it's a square from the center of the circle, we have a radius, which would be half the diameter, or a radius of 4 centimeters. So now we're moving into some subtraction. So the area would be the square, length times width, minus pi times r squared. Now I'm putting that in parentheses because we are subtracting it, okay? Just making sure that we are aware. The very last one has a parallelogram with an embedded circle. Now it's an entire circle, so we don't need to change our formula. But from the first lesson, guys, the area of a parallelogram is simply base times height, the base of 13, and we see a height of 6. And again, much like number 8, if we have a height of 6 or a diameter of 6, we have a radius of 3. So this would be base times height minus pi r squared. So right now you can go ahead and pause this video. You can make sure that you have everything written down and you go ahead and solve the problems and finish the activity quiz. After the activity quiz, there will be one last page I will send you with the link with IXL practice. When you are finished, you may either work on IXL that is due on Sunday night, which has been put on Homework Hotline, or you can follow the link in the Canvas module to IXL. Again, this will be checked on Tuesday for completion, so please make sure that you are paying attention and you are following along and completing the lesson as it has been shown.